Okay, in this question here, they're asking me to use limit comparison test to show that this particular series is convergent. And they have already given you a Bn. I suggested Bn is already there with us. So I call this as An and this is my Bn. And so I wrote them here, and the question is to apply the limit comparison test. And to apply the limit comparison test, I need to find out an by bn and apply the limit as n tending to infinity. And I see that I have got an expression here, algebraic expression, which is not a polynomial because of the square root. And even this has an algebraic expression which is not a polynomial, root of n cubed. So what I'm thinking is, like, you do n by bn and then square it. That is, you consider an square by bn square so that the square root goes away. So that makes it a little bit easier for me to find the limit of it. So that's the reason why I do an square by bn square. Look at an square. An square, when I do this, this is a plus b the whole square. So I did a square plus this is my 2ab term, and plus I have b square divided by root, goes away when I square it, and then divide it by bn square. So instead of dividing by a fraction, I multiply with the reciprocal of bn square. 2 is 4, which goes in the denominator, and the square root goes away, which comes in the numerator. Now I'm going to apply the limit to it, but before I do that, I try to kind of simplify this expression. So I'll multiply the numerators together, I'll multiply the denominators together. So this is what I get when I multiply the numerator, just opening the bracket with n cubed, and the denominator, 4 times 5 is 20, 4 times n raised to 7 there. And here I realize that if I need to apply the limit as n tending to infinity, I divide by the highest power of n term, which is n raised to 7. So I divide by n raised to 7 in the numerator and denominator. That's what I get in the numerator, and this is what I have in the denominator. So I'm ready to take the limit as n tending to infinity now. So I apply the limit as n tending to infinity of a raised n squared by bn squared. That gives me 1 because this term becomes 0, this becomes 0. So I have 4 by 4, which gives me 1. If the limit of an square by bn square is 1, limit n tending to infinity of an by bn would be square root of this. But it won't be plus or minus 1, it will be just plus 1, because we know that our an and bn are positive terms. Individually, an and bn are positive terms. So I have limit n tending to infinity of an by bn coming as 1, as they both are positive. So if, according to the limit comparison test, if limit n tending to infinity of an by bn is 1, that means that sigma n is equal to 1 to infinity of an as well as sigma n is equal to 1 to infinity of bn would both have the same nature. Either both will converge or both will diverge. Now how do we decide on that? So it is depending on bn. So we have a bn here, which I can see is 2 divided by n to the power of 1.5 square root. So when I consider the corresponding series to it, when I consider the corresponding series to this, it is going to be 1 by n to the power of 1.5. That's your p-value, and p is more than 1, so it's going to be convergent. So this converges by the p-series test. And if sigma of bn converges, then sigma of an also converges. So that is the first question. That's the question given there. So the given series converges. We look at this question here now. So to determine whether these two are convergent using comparison test, One thing what we need to realize is that these are two separate questions. They're actually asking you to show that this is convergent series. After you finish that, you try and prove that this is also a convergent series. So we consider the first one, sigma n is equal to 1 to infinity of 1 by n raised to n. I know that 1 by n raised to n is always positive because n belongs to z plus. What I am trying to set is figure out a function which is always bigger than that. 1 by n square will be bigger than or equal to 1 by n raised to n. As for example, checking when n is equal to 1, this will be 1 and this will be 1, they are equal. N is equal to 2, 2 raised to 2, 1 by 4 is less than or equal to 1 by 4 again. If n is equal to 3, 1 by 3 raised to 3, 1 by 27, and this is 1 by 3 square. 1 by 9. 1 by 9 is bigger than 1 by 27, so it's going to be true always. So we apply sigma throughout. Sigma n is equal to 1 to infinity of 1 by n raised to n less than sigma n is equal to 1 to infinity of 1 by n squared. But we know that this by p-test converges, and if it converges, also the sigma of an converges. Looking at the second series, 1 by n factorial, 1 by n factorial is 1 by n into n minus 1 into n minus 2 into etc. into 3 into 2 into 1. What I'm going to do here is trying to get a bigger expression than that, trying to set a bn. I will retain 1 as it is, 2 as it is, 3 will be replaced by 2. Then I have a 4 here which will be replaced by 2 and so on. N minus 2 will be replaced by 2. N minus 1 will be replaced by 2. N will be replaced by 2. So all these numbers until 3 I replace it by a smaller number. So if I do that, the denominator becomes all 2 into 2 into 2 into 2 until this term, and the 1 remains there. So every single term in the denominator has been replaced by something smaller than that, so it becomes a bigger expression. Now you will realize that here we have got 2 repeated n minus 1 times. Now when I apply sigma on this, the right hand side one, my bn becomes a convergent series because it's geometric. 1 by 2 raised to n minus 1 is a geometric series, and the common ratio of it is 1 by 2, which is less than 1, so it converges. And if that converges, sigma of an also converges by comparison test.